Hi guys, we just finished up our digestion in order to do our assembly. So I took our PCR strip out of the incubator and we're going to get it ready to run a gel. So in order to run a gel, we need to add a little bit of loading buffer. This is 10x loading buffer. So you're going to add 1 microliter for every 10 microliters of actual digestion mixture you're going to do. But you don't need to be that accurate. I'm just going to set my P20 to 3 microliters and I'm just going to load 3 microliters per sample. And I figure that kind of averages out. I have a 20 microliter reaction and then 2 1 microliter reactions. So just get your P20, set it to 3 microliters, pull up 3 microliters, check the volume, make sure it looks about right, and you're going to want to open up your tubes and just drop it on in. So this has glycerol and some dye in it, and the glycerol helps the mixture sink to the bottom of the well when you're loading it inside of the gel, and the color also helps you kind of visualize how far the gel has run, as well as it helps you load it, and it also provides some buffering conditions so that the gel will run properly. You don't need to mix it well at this point, but just put your loading buffer in there. Now you can see we have liquid with some blue stuff on the bottom. So now we're going to take this over to our gels. Over to our gel box. And we can just place it right next to that little, right on top of this tip rack. And I'm going to get a gel out. So we pour our own gels here. And the way I do it is I have 3 samples. So I'm going to run 3 lanes plus a ladder. And I always like to add a couple of buffer lanes, like extra lanes on the side of the ones that I'm actually using, because if you try to run gel with a sample right next to a cut mark, it just doesn't work for some reason. So I have 1, 2, 3 samples plus a ladder is 4, plus 2 buffer lanes is 6. So I'm just going to count out 6 lanes. 1, 2, 3, 4, 5, 6, and then I'm going to cut right down the center of that 7th well. Going to put the rest of the gel back into that gel box, or the gel storage area, and then I'm going to lift off the cover of our gel box, put the gel inside of that gel box, and we only have half of a gel here, so I take this little comb and I use it to stabilize gel. So now it shouldn't move. Now we're actually going to load our gels, so I just pull up my samples, grab P20. These P20s have been contaminated with lithium bromide, so they do not move. They stay here. You're always wanting to use gloves whenever you're working around here. You have to be extra careful that you're wearing gloves. And once you've touched the lithium bromide, once you've touched the gels or anything in this area, these gloves get thrown away because lithium bromide is potentially carcinogenic. So here's our sample 1. We put our loading buffer in it earlier, and now I'm just going to mix it up and down with my pipette tip. So now it's been evenly mixed, and I'm just going to plop it into that well. So there's our first sample. We're doing a prep gel, so we actually want to switch tips. If you're doing an analytical gel, you can just use the same tip. So I'm going to do the same thing. I'm going to move it up and down and then pull it out, and now we have a nice evenly mixed sample with buffer and digest. Load the gel, and you can see how that loading buffer gives it a color that allows you to see what's going on, and you can see how the glycerol just makes it sink to the bottom. So there we go, last sample. And now I'm going to just leave this to the side so I know how I've loaded it, and we're going to add our ladder. Usually add about 7 microliters of ladder, and this has already been mixed with buffer and it's good to go. So 7 microliters. Kind of a quick tip, if you want to do precision pipetting, you can put your finger right there and it'll help you guide it in. And we're good to go. So now all we do is, put our comb in right next door, and hopefully that'll hold it. There we go. And put our covers on the gel. Gotta aim it just right. And you always want to make sure that you're running towards red. So DNA has a negative charge and red is the positive charge. So negative runs towards positive. So your DNA should be on the far side of that gel. So running towards red, double check that red is connected to red, which is at the bottom, and that this wire is eventually connected to the red at the power source. I just plug this thing in, make sure it's all plugged in, and then I'm going to set my time, or rather we're going to set our voltage to about 180. Amps don't change, and we're going to set our time for 12 minutes. And then just hit run. And if you look closely, it might not come out in the video, but there's a wire running along the bottom, and there's bubbles that are coming out, and that just tells you that it's running properly. A couple of other quick pointers. When you put your gel inside of the gel box, you need to make sure that it is completely covered in running buffer. If the gel is peeking out of that running buffer, then your gel will not run properly, and you need to top it off with deionized water. You don't want to put more gel buffer in there, or running buffer, because you'll throw off the osmolarity of the gel run. So always use deionized water. Another thing is that sometimes the water will, or rather the buffer will heat up. It's okay if it's a little bit warm, but if it gets too hot, you may start to melt your gel a little bit, and hotter gels don't run true. So just be aware of that. You may need to either find another gel box or ditch the buffer and run it in fresh buffering conditions. Finally, if you're not using a timer on your power supply, set yourself a timer at your bench, because it's very easy to run your parts off of your gel. That's no good. If you run your part off of your gel, then it's gone forever. You need to redo everything. That's all I can think of for now. We'll be back, and we're going to snap a photo of this gel, and then we're going to cut out some things. We're going to cut out the DNA bands that we're interested in, and we're going to purify them, and then we're going to go into a ligation from there.